Okay, so today what we're going to do is you were already supposed to have SQ3R lesson 2.5. So we're already supposed to have an idea of what's going on. All we're going to do is do some more practice in it. So on this next page in your notebook, or continuing on your SQ3R page, I want you to put the title lesson 2.5 practice. So we're not necessarily going to state any of the objectives. They should already be in your SQ3R. We're not going to actually put any tips there for us. We're just going to practice some problems, okay? Yeah. So, number one, the first problem that we're going to practice, what's going on in lesson 2.5 that was not going on in lesson 2.4 when you were solving inequalities? Okay, what's going on in somebody who SQ3R'd actually gets to answer this? So if you actually did do it, Brianna?
There's variables on both sides.
Okay, we have to solve inequalities that have variables on both sides. Okay, so what happened when we're solving them with
14.
Okay, what happened when you were solving those of you who actually did do your SQ3R? What happened when you were solving these? What are some of the possibilities? When you have variables on both sides.
A no solution or
A no solution or a
all real number solution.
all real number solution or yeah, a typical our variable is still there and it's either greater than or less than, or and we have just a certain region that is a solution, right? Okay, so those are the three possibilities of what can happen. Okay, so let's solve 7 plus 4x is greater than or equal to 3x. Now there is actually more than one first move you could make, but typically we want to make what we think might be the most efficient move first. What do you think we should do first to both sides of this inequality? Ricky?
Subtract 4x.
Subtract 4x. Okay, let's get the x's eliminated from the left side, because the x's are already alone on the right side, so that's a pretty good choice of a move to make. 3x take away 4x is negative 1x. And our next move would be divide by negative 1. Divide both sides by negative 1.
The symbol switches.
And because we're dividing by a negative, as Logan says, we have to switch the symbol. So this is what's 7 divided by negative 1, first of all. Negative 7. And instead of is greater than or equal to, it'll become is less than or equal to, and we'll have our x. What is this also known as if we want to have it so the variable's on the left side rather than the right side?
X is greater than or equal to negative 7.
Okay, x is greater than or equal to negative 7. I'm still going to recommend that for some of you in here, it's in your best interest to switch it around because you're getting the right solution, but then you're not getting the right graph. Okay, so take the time to flip it over and read it from going the other direction, because now when we graph it, hopefully we will have the correct shaded region. Open or close circle at negative 7.
Closed.
Closed. And what numbers are greater than negative 7?
Negative 6.
Yeah, the negative 6 and going in that direction. So our graph is actually shaded to the right. Once the variable's on the left side, then the inequality symbol is actually pointing in the direction that the shading should go, isn't it? We can count on that, but we can't count on it the other way around. Any questions on that one? Okay, number 2. We are going to solve, but before we solve, we're going to have to do some simplifying. So we have 4 times 2 minus x is less than or equal to 5 times x minus 2. Is 2 minus x the same as x minus 2?
Yes.
No, subtraction doesn't allow them to trade places, does it? They really are different expressions. Okay, so first we're going to simplify. What property do we use to do that? Distributive property. Yeah, we got to do distributive property. Okay. Now you can change to add the opposite first.
Do we have to?
But you don't have to. You decide what's going to work for you best. And this one is pretty efficient to keep it as it is, but if you also change it to add the opposite because that's just a good habit you've gotten into, then do that. So what do you think our first move should be in this one?
Add 4x.
Add 4x to both sides? 4x is being subtracted on the left side, and so we're thinking that if we add 4x, we won't have to deal with any negative x's?
Yes.
Okay, so then we're going to have 8 left alone now on the left. And what's our right side become? 9x minus 10. Okay, you go ahead and finish that one out. Oops, lost my equality symbol. Anybody need to challenge what I have, or do I need to challenge what you have? Or
I bet you didn't grab it.
I haven't grabbed it yet, have I? I'm gonna check to see if I have the right inequality. So.
Yeah.
Should I reverse the inequality symbol?
No.
No? Okay. And without reversing this, can anybody tell me what direction do I need the shading to go?
Right.
To the right, okay, because this really says 2 has to be less than all the shaded region. That's what X is, the shaded region. So 2 has to be less than all the shaded region, is it?
Yes.
Yeah, okay. But if we do want to switch it around so that we make sure we're more successful, that's
Right. X is
greater than or equal to 2. Is that what our graph says?
Yep.
Yes, it does, okay. Questions? We have 5 to do, so we're almost half done. We're on number 3. Number 3, I want you to solve an inequality that, again, is going to need some simplifying before you solve it. Make sure you copy that down correctly to start with. And let's see what happens in this one. I just took the time to change it to add the opposite. And I'm kind of afraid if some of you don't, that where it's going to go wrong is right here. But maybe not. You can do it without changing it to addition, add the opposite, and still get the right thing. That's okay. What would be my next move here? What was your next move if you agree with this? Ricky?
Add 3.
Add 3?
Add 3 there.
Oh, 3x. Okay, well, because I gotta know there's a.
Uh-huh.
Add 3x to both sides. Okay, what do I have now?
6.
6
is
is
less than
less than
0 per
3.
3.
Is there a
Oh,
3 left over
oh,
there?
yeah.
Okay, I got it circled though, looks like a 0. Okay, so we have 6 is less than 3. This is no solution. Why?
Because you have to, it has to be.
The x's are gone,
There's no
and
It's not true.
that's not true. So, Jonathan.
I made it 0 and then subtracted the 3. So on both sides, I
Okay.
made it 3
Okay,
is less than 0.
so you have 3 moved over. Okay.
Yeah.
And that works too. Yeah,
Oh,
we may not
I
all,
made it
depending on the steps we use, we may end up with a different statement here. But in your case, And anyone else's who might have had a different, did the X eliminate?
Yes.
Okay, so we want to put that in our notes, so we know the X eliminated, and 6 is less than 3 is what? True or false?
False.
False. 6 is less than 3 is false. So that leads us to our final conclusion, that there is no solution to this inequality. There is not a number on the number line that would satisfy this inequality. Now, is there any reason to graph this?
No.
Mm-hmm.
Because there's nothing to shade, right?
Yeah.
We could make a number line if we really want to. But then, could we
There's
shade
no
any part of it?
No.
No, there would
There'd
be,
be no reason to
no
do that, 'cause
reason.
you're just waiting for that.
yeah, there's no solution for it. We don't want to waste lead, yeah.
I don't want to waste the time.
Or the time, yeah, maybe that's just as important.
We don't have-
Okay, any questions? Where should we, anything we need to talk about in this one?
No.
Okay, the next one. Number 4. We are going to solve 4 times the difference of x and 1, and that is less than or equal to 4x. So we need to do some distributive property first, so simplifying first. And then we'll go to work solving it. What first move do you want to make this time?
Oh,
Oh, boy.
What are you going to do, Ricky?
I subtracted
4?
X.
4x. Okay, which one is it?
4x.
4x. You want to subtract 4x from
Yeah.
both sides? Okay. Subtract 4x, subtract 4x. What do I have now?
Negative 4.
Yeah, this is what's left over here. Negative 4 is less than or equal to 0. When you take something away from itself, you now have 0. Okay, so
True.
is that true?
Yes.
Okay, well then what does that tell us?
Then it's only between those.
Is it only between those two numbers?
No. Yes. Because they have the negative 4.
So for those of us who SQ3R this lesson, what happened in the lesson, Brianna?
This question would be all answers.
Yeah. If we end up with, again, we're going to state why the reason is, the x eliminated, or if the x eliminates, or whatever the variable is, in this case it just happened to be x, the x eliminated and negative 4 is less than 0 is true.
Isn't it less than or equal to 0?
Yeah, I'm sorry, I missed the equal to part in saying it. I wrote it, but I didn't say it. Okay, so the x eliminated and negative 4 is less than or equal to 0 is true. So that tells us any number you want to pick off the number line would be a solution, so we state it as all real numbers. It isn't just the numbers between negative 4 and 0, and let's prove that. Let's use, I don't know, 10.
10
Is 10 outside of that territory? Is 10 between negative 4 and 0? Okay, so let's check one out that is outside of that territory. So 10 take away 1 is 9, and 4 times 9 is 36. 4 times 10 is 40, so 36 is less than or equal to 40. True or false? True. So that 10 is a solution also, isn't it? There is not a number we could choose. We could stand here, not let you guys out of here for Halloween and do this for
Not a good
Long time.
idea.
That is not an option.
That's not an option? Okay. Yeah, I don't. Okay, one more. Number 5. I'm going to give you a written statement, a word description, and you're going to first set up your
Oh, boy.
Oh, wait.
inequality, and then you're going to solve that.
4 more than twice.
Okay. 4 more than. Twice a number is greater than 2/3 the number. Which words in there tell us that are the inequality symbol? More than? Is greater than? Which one?
Is greater.
Both of them. Or both of them. Is greater than. Remember, in an inequality symbol, the word is included. So these words right here, is greater than, tells us what our inequality symbol is going to be. What does the more than do?
Tells you you're adding.
Tells us we need to add. Now, if it would have said for is more than, would we have used the inequality symbol? For is more than 3. Wouldn't we use the inequality symbol then? So when the word is included, that's when we know it's the inequality symbol. Okay, so what would our inequality statement be here?
2x.
4 plus 2x.
4 plus 2x is greater than 2/3 x.
Oh, I
Okay.
get
You can use n. Sure. N for number. That works. Okay.
I got the same way concept you wrote it.
So you just have the n in place of the x's. Okay, that works. Now there's 2 ways we can go about this one. And I actually prefer one over the other, and I'm going to give both of them to you, and then you decide which one do you think might be worth, trying. We can rename the 2x as thirds so that when we have to add or subtract, that whichever side we decide to move them from, they're going to have a common denominator. Because don't you have to have a common denominator to add and subtract fractions? Okay. We could do that, or I'm back in another lesson when we had denominators that we wanted to get rid of, we multiplied every piece of the equation by that denominator. So we could multiply every piece of this equation by what? And it would get rid of the fraction for us, the 3. So which one do you think you like?
Get rid of the 3.
Get rid of the 3? Good choice. Okay, let's take every piece times 3. So the 4 is going to get multiplied by 3. The 2x is going to get multiplied by 3. Remember, if you multiply or divide, especially you got to do it to all pieces, and we have 2 pieces on the left side, and then we're going to take this side times 3. Well, 3 times 4 is 12.
6x.
3 times 2x is 6x, because 3 times 2 is 6, and then we just have that times x. And then is greater than, well, let's put this over 1,
2x.
because then the 3's will cancel, and we'll have 2x over 1, which is 2x, isn't it? Okay, so we're going to have 2x. Okay. I'm thinking that now we don't, this is much quicker than if we renamed that 2x as thirds, made it 6/3 x, and then we had to subtract, and then we'd have 4/3 x. Oh, it would just be a lot more work, wouldn't it? Okay, so what are we going to do now?
Add
Subtraction.
6.
Subtract
6x.
6x, okay. And now we have a 12 left over here and
-3.
negative 4x, right?
Yeah.
Yeah.
I did it
Okay.
Well, I get the right answer. I just did.
Next, what do we do?
Divide
by
negative
negative 4.
Divide by negative 4.
-3.
Negative
These guys cancel.
less
And
than.
then you got,
Negative
first you
is less
sign,
than.
And switch the sign because we
divided by negative.
divided by a negative. Now, we have to graph this yet too. So on a graph,
-3. into the
Negative
right, you want
3.
-2.
negative
To the
2,
left, you want -4.
negative
An
4,
open circle to the right.
and shade to the right.
Yes.
Okay. Why are we going to shade to the right?
Because x is greater than -3.
Because when we rename this, it is also known as what? X is
Oh,
greater than negative 3. So, this one, if we want to rename it, this one went through a double switch, didn't it? It ended up back the direction it was, but only because first we had to switch it for dividing by a negative, and then we switched it to rename it. So there's, there's a double switch going on there, but we don't always do that, okay? So, any questions?
Negative.
Okay, then let's start some homework.